Okay, this is section 7.2 where we talk about volume and one particular method, the disk method. But what's true in chapter 7 more generally is just that we're modeling things that the model turns into an integral. And so the whole idea is if I need to add up a bunch of stuff, so I'm going to sum up a bunch of stuff, if I can write it as some function of some xi times a delta xi, or a delta x that's related to that xi, and I can sum this up in such a way that we can let delta x I go to 0 for each of those i's, then we can turn it into an integral, and those are easy. Well, sort of, right? As long as we know antiderivatives, that kind of thing. So in 7.2, we get this disk method for volume. And so, if I just have, some shape like this that does look like it is sort of made out of disks. I did a kind of a poor job there drawing. But, if you slice that thing up and you said, oh, okay, well, I'm going to take this slice out here, and if I look at that slice, it looks kind of like a disk. Now notice, I tried to keep the fact in here, these aren't perfectly square, but as I make that slice smaller and smaller and smaller, so I just slice more and more and more times, then it does, definitely start to look like a real live disk. And if I know the radius of that disk, r, and I know the thickness here, say h, we'll call that for a height. If I know those two things for a given disk, then it's just pi r squared for the base area, and then times the height, h, and I get the volume of that disk, and then, well, I just want to add all those up. Well, okay, what does this have to do with integrals? Well, you see the sum part certainly looks like it's heading that way. But if I, in particular, take this thing and I tip it on its side, and I just sort of think about the silhouette here. And so suppose I put it on its side and it looks something like that. All right, and if I did the silhouette and had it nicely centered, it would, do something like this. Well, if I can describe this curve with some function f of x, then all I've really done is I've tipped over the original picture I had there onto its side, and when I take a slice of it, that radius I had is my f of x. And the height I had, that h, is a delta x for some piece in there. And so this one slice, as I think about it, it's going to be pi f of x squared and then times delta x. And so that's one of them, so I could put an I on that. And then sum those up. I equals 1 to n. But now let my delta xi's go to 0 and little n there go to infinity. And I will have, now I don't know if that's say 0 and that's 2 or something like that. I would have an integral from 0 to 2 of pi, and I'll write it as f squared of x like that, dx. And as long as I can find the antiderivative of that thing, fundamental theorem of calculus, and I'm good to go. Okay, so that's the basic idea, is that if we can model a given volume by a disk, and in particular, typically the height of that disk is going to be like a delta x or a delta y or something like that. If we can do that, and we can get the overall shape in terms of some function f of x, the overall silhouette of that thing, then we have a model for the volume that we can take the limit of and produce an integral. And so that's what we're doing in 7.2. We're just trying to build integrals, but in particular, we're thinking of disks every time in this particular section. So that's what we'll do.